My name is Asa Bondison, and we are the TCAS systems team for Lockheed Martin, and we're going to give you guys just a quick overview of what we've got going with our project so far. So the prototype development updates as far as what we're concerned with Milestone 12. So we're going to talk about a little bit what you can expect to see here on these slides. So we used Papyrus, and we did a couple of different production phases with the BDD, IBD, use case diagrams, and activity diagrams. We got some visual aids for you guys as you kind of walk through this PowerPoint with us, and we'll be taking you to the actual inside of the software to kind of get an actual view of what you're looking at.
So this is our BDD, block definition diagram. The way BDDs work, they start with the topmost avionics level component and branch down into the extended subsystem components. Our main vessel is the C-130J, that's our topmost avionics component. This is our first subsystem we're dealing with, which is the intercom. And then from there, we're going to be branching into the BSU and the ICS. The second subsystem is the communication system, and this is going to be dealing with the communications and navigations management unit. The third subsystem is the navigation subsystem. This subsystem has a deeper level of hierarchy between the subsystems. The first subsystem within the navigation subsystem is the actual TCAS system. The TCAS system functions off of two components, the antenna for signal transmission and the TCAS processor, which is going to be handling the data. And from there, these are the lowest level system components, and it'll make more sense of the connections in the IBD diagram of where the lower level system components connect. So the second subsystem in the navigation subsystem is the GPS, and the third is the autopilot subsystem. The fourth component within the navigation subsystem is the air data computer. And moving to the third subsystem within the C-130J network is the heads-up display. The fourth subsystem is the mission processing, and the final is the 28-volt subsystem that handles the electrical connections that will be used within the IBD and control the overall electrical connections of the physical components.
Next, we move into the internal block diagram. This block diagram is designed to show you how the actual connections inside the airplane are made. So starting off with the bottom level that he talked about earlier was the TCAS. So start off with the TCAS system, which has the antenna, which connects to the TCAS processor through the RF kind of line, and it gives the TCAS processor the RF information, which then is powered by the 28 volts. And then this TCAS processor will send data to the higher level system of the navigation internal block diagram, which will be able to send communication data and the TCAS data outside. And then these all systems are built into each other to show all the connections. And then it will finally come out to the TCAS entire block diagram, which will show the entire connections throughout the plane.
So this right here is a little depiction of our use case diagram. So more or less the use case captures a contract between the stakeholders of the system about the relevant behaviors within said system. And it looks rather simple, but so basically, as you can see within the picture, the pilot is in contact with the TCAS advisory analysis as well as the communicative advisories, whereas the flight crew is simply in contact with the communicative advisories.
For our next diagram, we did a requirements table. The components that you guys saw previously in the BDD and the IBD are gonna have to conform to these requirements. We spoke to our client and got a good amount of requirements, but also through background research, we were able to come up with our own. We split up the requirements between avionics level and systems level for ease of understanding and just to track it easier. In detail wrote what each requirement is and what kind of factor needs to be satisfied.
Or the activity diagram is basically going to serve as a simulation of the model. So it's going to simulate behaviors and activities that are going on between the components. After discussing that with our client, that's basically going to look like the final simulation of the product. So whatever the model is going to do is going to be kind of captured by that activity diagram. We haven't started yet, but we do have ourselves in a good position to begin that and in turn wrap up the entire model.